Figure 15-1 from Stallcup's Electrical Design Book, Volume 2, deals with calculating amps of loads. For example, look at the first load at the very top, and notice the load is 120 volt single phase, 1,920 volt amps. So we can always use the front inside cover of Stallcup's Electrical Design Book, Volume 2, and we have a wheel there with our formulas, and you're looking for the current, so you take the VA divided by the voltage, so 1,920 divided by 120 is 16 amps. So the load from that circuit breaker over to that unit, the load would be 16 amp. But you would calculate it at 125% if it was continuous, and if the load operated less than 3 hours, then it wouldn't be considered continuous by the definition of continuous operation or continuous duty in Article 100, so we'd remain at 16 amps. If not, multiply 16 by 125%, that'd be a 20 amp breaker with number 12 wire, per 240.4D and 210.19A1. Now the second load that we see is a 208 volt single phase, 10,400 volt amp. Now notice the same thing, current, voltage, VA divided by the voltage, so we'd have 10,400 VA divided by 208, 50 amp. And then again, you evaluate, is it a continuous load? Is it a non-continuous load? Or is it a load with demand factors? And if it's a continuous load, again, multiply it by 125%. If it's a non-continuous load that operates less than 3 hours, just stay at 50 amp. If you have a demand factor on it, say like 80%, it'd be 80% of 50, and that would be your load, say. So the next load that we see is 208 volt three-phase, 10,800 VA. So again, the current is equal to the volt amps, 10,800, divided by 208 volt times the square root of 3, and we just kind of round it and leave it at 360. Divide that 360 into 10,800 VA, we come up with 30 amps. And then you treat that load the same way, continuous, non-continuous, or a load with demand factors. And that's what this figure 15-1 is illustrating, converting VA based upon the voltage to amps.